Today's lesson is section P5 and we're on day 4 and we're looking at complex fractions. So complex fractions are fractional expressions with separate fractions in the numerator, denominator, or both. So meaning we have fractions inside of fractions. So we're first going to look at this example and notice how we have 2 over x minus 3 in the numerator. So we have a fraction in the numerator of a fraction. And then it's divided by, or in the denominator, 1 minus 1 over x minus 1. So the first thing I like to do is rewrite this division so that it's horizontal. So 2 over x minus 3 over 1, and I will make everything into a fraction, divided by 1 over 1 minus 1 over x minus 1. So our first goal is to have one fraction being divided by another fraction, because right now I currently have 2 fractions divided by 2 fractions. So we need to simplify each of them to get them as one fraction. So to do that, we have to remember back to the beginning of the year when we add and subtracted fractions. We need to find a common denominator. So the common denominator for these first 2 is just x. So my first one doesn't change. My second one already had a 3 and it was missing the x, so that's 3x. The second denominator is going to be x minus 1. It's very similar to what we did the other day as well. So this first fraction here with the 1 was missing the x minus 1. It had a 1 in the numerator, so x minus 1. This one already had it, so it stays the same. It's not necessary to write that 1, so I'm just going to get rid of that and get rid of my parentheses. All right, now that I have a common denominator, I can rewrite each of them as one fraction. So in the numerator, it's 2 minus 3x all over x divided by x minus 1 minus 1 all over x minus 1. So this minus 1, we can simplify that to be minus 2. So I will just go ahead and do that. All right, so now that we have one fraction divided by one fraction, I'm going to keep the first fraction the same and change division and multiplication and flip my last fraction, or multiply by the reciprocal. So x minus 1 all over x minus 2. And then we're going to look at this and say, okay, I'm multiplying fractions, so I'm just going to multiply straight across. So 2 minus 3x times x minus 1 all over x times x minus 2. And with like the last couple lessons, we have to look at this and say, okay, everything's already in factored form, so can I reduce anything? And looking at this problem, nothing in the numerator will cancel with the denominator, so we are all done with this problem. I'm going to skip example 2. It's LCD method. And if you'd like to see that, let me know. I just know usually students prefer this first method, so we'll just stop there, and because I don't want to confuse you anymore. But I will do one more with you. We'll do this first one here. All right, so again, this one's pretty, it's pretty nice, because if I look at it, I already have one fraction being divided by another fraction. So I can already keep the first and multiply by, by the reciprocal. So if I multiply straight across, remember, leave everything in factored form, then I can say, hey, my x's cancel. On the denominator, I have 2 of the x plus 1s. In the numerator, I have 3 of them. So that means I have 1 left over in the numerator. So my final answer is just x plus 1. So not all of them are quite as complicated as the last one. And we'll go ahead and do this your turn as well. I'll go ahead and do this since it's the last one with the LCD method. That way, if you're curious to see what it is, you do have an example of it. So the LCD method is you have to look at all of your fractions. So total, I have 1, 2, 3, 4, and say, okay, what is the common denominator of all 4 fractions? Well, the common denominator is x squared, y squared. So I have to multiply every single one of these by x squared, y squared. So x squared, y squared, x squared, y squared. All right, so I'm going to go ahead and write this out before we start canceling things. So I have x squared, y squared, all over x squared, minus x squared, y squared, all over y squared. I'm going to go ahead and write my division horizontally. Then I have x squared, y squared over x, plus x squared, y squared over y. So now I can go through and start canceling some things. So these two x squareds are gone. Those y squareds are gone. So in this first part, we are just left with y, forgot my square there, y squared minus x squared. Okay, divided by, now let's look at the next one. This x goes away with one of those. That y goes away with one of those. So divided by, oh, my fraction's gone, so xy squared plus x squared y. So now I wrote it like a division problem horizontally, but I'm going to go back and rewrite it vertically. I was going to do two things at once, but I'll do this first. All right, so the LCD method just eliminates all of your fractions. So now I can see what I can simplify here. So y squared minus x squared, well, that's just difference of squares. So y minus x times y plus x. In the denominator, I can factor out an x and a y. So I'm left with y plus x. My y plus x's cancel. And we are left with y minus x all over xy.